Okay, hello, good morning everyone. So this is once again Dexter Mogera, so your faculty instructor for this course. So I'll be discussing about the introduction of this course, which is all about the let me see on the syllabus. It's all about integration. Okay, so after the end of this discussion, you will learn what integration is all about and how it's being related to this course. So hopefully we will have time to discuss also the inter-system communication. Okay, so yeah. So again, looking back on our course description, so this course covers topics on asynchronous message, so please keep that in mind. Also for SACS, DOM, data stream transformation, it will expose you learners on design, development, debugging, and testing application programs with the messaging service. So I've mentioned on the class orientation that you should have enough idea about the object-oriented programming, how its concept being applied on making a program. Also, it requires fundamentals of programming, which is your IT 13, and I believe you're all capable and be able to make a program along with your learning on the concepts of programming. It mentions about asynchronous message. So with this, after this discussion, you will learn what's asynchronous message is all about and what are the technologies involved during the process. I will show you a simple architecture later on, a simple system architecture, so that you will have a bit of idea what's asynchronous message is all about in terms of system integration, in terms of the system architecture. We will also have a bit of understanding about the SOCs, the DOM, which are XML parsers. So I believe it's necessary that we learn XML parsing or parsing other files, not just XML files. So this is very important as we are about to, as we will be able to let files migrate from one system to another. So when a file travel from your system across the network, so we don't have we don't have a ways initially. We don't have an idea on how to protect our data traveling across the network. So it's necessary that we parse it, we encrypt it, so that someone could access that data in the network. So it won't make sense to them. It's because your data are being encrypted, and it requires a specialized algorithm or equipment or tools to decipher it, to encrypt it, to decrypt it, for a specific attacker could understand the data. So it could add security, it could add a level of security on your system. It could add another level of security on your system, especially those systems that are communicating over the network. Okay, so leave a comment on the forum if I am too fast discussing this to you. Okay. Also, data stream transformation. So we're not be dealing about single data alone. We'll be dealing with streams of information, streams of data that are migrated from one or travel from one system to another. So we'll have to be dealing with multiple transformation of data. So it will expose learners on design, development, debugging, and testing application programs with a messaging service. So of course, we will be implementing an asynchronous message. So the process for transmitting data from one system to another in a form of message, so it requires messaging service. Okay, and we will transform a data stream to another format and onto operating scripting language. So we'll learn about operating scripting language for the management of operating system. No, not just programming language, but we'll be dealing with scripting language. So as I mentioned on our first meeting, that scripting language and programming language are a different matter. So they are specialized tools that we could use in order to leverage or take advantage uh, of implementing an application or system. So not just programming language that would access the high level features or functions of an operating system, but also the scripting language. It's a powerful tool, especially when we're dealing about things that is going on the web. Of course, we're dealing with multiple systems that are communicating, so it involves network, it involves the web. So therefore, the current trend today is using a scripting language. So therefore, it has to be included on our discussion. So that is why. Okay. Okay. So yeah. If things being discussed so far is not really clear to you, so leave a comment on the forum. I'll leave a forum on the LMS so that when you ask questions or concerns, so your classmates will see that also. Okay, so this is an asynchronous message, a simple architecture implementing an asynchronous message. So the idea of an asynchronous message is that when you pass data from one system to another and it's a message, so basically it should have a capability of being asynchronous. When we say asynchronous, it's not happening at the same time. It's not time dependent. It's time independent. So to make more things clearer, so when you send a message, you don't necessarily the recipient don't necessarily wait for that message to arrive. So there are some instances that when you send a message, you don't bother about the message being sent. All you know is that the message being sent is the message being sent. So the message being sent, you will know eventually that the message will arrive on the recipient. In in the in the opposite idea, so in the recipient side, it won't necessarily wait for the message to arrive. It's because he will know, the recipient will know that the message will eventually come. Uh, um, so yeah, in order to implement such a manner, so you will have to integrate some sort of useful technologies in order to do that. So uh, yung ano kasi yung Tagalog na ko. So ang idea man good is that when we send a message, what if the network would fail? What will happen to the message being sent, no, from the web client to the backend service? What will happen if we rely solely only on the network? So when you send a message and if the network fails, what will happen? The message would somehow be gone, or become deleted in the network, or the message would go back to the client, and then kuan man gud kanang dili kaayo reliable kung ang imong system architecture ingon ana siya flow. Dapat somehow when the client send a message, it should it should the system should give a feedback or response message that your message na-send na gyud dito sa backend service. Pero ang idea di ay wala pa ma-send. Pero kabalo ang client na assurance nga ang message mo arrive gyud eventually despite of the dynamic nature of the network. So, yeah, akong balikon, ang problem mo before sa simple nga architecture, kung wala ning integrator, wala ning broker, wala ning JMS, kaning nasa tunga bitaw, kung wala ni dili ingon ana ka dynamic ang imuhang dili ingon ana ka dynamic ang imuhang duha ka system nga nag-communicate. Dili pud sila ingon ana ka seamless. Kay kung wala ning nasa tunga, no, wala ning mga technologies involved during the process, we can implement asynchronous message. It's because kung mag-send kag message ug nag-fail ang network, so ang message mo balik ra na sa web client. Thereby, what will happen? It's an inconvenient sa end ni web client kay ang iyang transaction wala na perform, something like that. So we don't do that. It's in this generation dapat flexible enough na ang imuhang system nga mo adjust depending on the dynamic nature of our of the current environment. Kay di magina ang likayan mo fail ang mga system, di ba? Mo fail ang network, mo fail ang database. So what will happen? We will give a bad response sa client. So in a business sense, so wala na kaayo yung mga clients, no, dili maka-gain og clients ang business kay error prone man, no? Error prone man ang system nga gigamit, no, sa business. So dili kaayo makadrag og mga customers and clients ang business. So dapat ang system nga imuhang i-provide diha responsive, dynamic enough to the changing environment of the business. That is why we need to implement the idea of a synchronous message, that when a web client performs a transaction, say for instance he will send a message, it should be asynchronous. The idea of a message being sent as an asynchronous message is that when the web client passes a message, the system would return an immediate response of saying the message has been sent or something like that, or the message will arrive to the recipient soon or something like that. So the idea is that the client would be confident to use the system. It's because you will give an assurance or a promise that the message will eventually arrive, dili man karon or maybe later, something like that. So dapat seamless ang process sa imong system. So we can do that. We can implement an asynchronous message with this example, no, na ay integrator in between sa communication ni client o ni backend or ni server or ni backend service. So na ay in between, no, to help the process become asynchronous. So we have this integrator, no. Let's assume that this integrator is also another server obtaining an HTTP listener, obtaining an HTTP sender. So this has been programmed. The integrator server also has a JMS sender and the JMS listener. This integrator server is dedicated alone on receiving and sending receiving an HTTP request and sending back an HTTP request, so that when web client access it, so this integrator will become a somewhat a proxy of the backend service. Say for instance murag representer ba, so when that client attempted to communicate the backend service, the integrator would say, yeah, I received the message, so that web client would know that the message has been arrived. But in reality, it doesn't, because the integrator handles it as if he or she as if the integrator is the backend service. Okay, so the integrator would listen and send a response saying that the message has been received. And then integrator would communicate on another service called a broker. So the integrator would pass the message to the broker. So he will use the GMS, no, the Java Message Service. So that is why I wanted you to study in advanced Java, because in our later in our succeeding meetings and laboratory exercise, we will be using Java. We will implement this kind of architecture. So I'm sharing this to you so that you will have idea, or maybe um, have an excitement on what will be dealing in the future. So yeah, the integrator have a GMS installed in it, and then it has a capability of sending a message to the broker service. So this is you can think of this broker as another server na pod. So when the message will be sent over from the integrator to the broker, so the broker now will handle the message. Um, this is the broker is very important as it will queue all the transactions, or all the messages, or all the requests from the client in a queue format. So the first in first out, or I don't know what type of what type of sequence he will use, or queue he will use, maybe a stack, last in first out. So it depends upon the programmer's choice or the client's request. So he will queue the service. This is necessary, queuing is necessary because no, I will explain first the broker. This broker will save, no, will store, will provide a temporary database for all the message, or all the task being, or all the message being sent from the client to the server. So this is very important, as all the transactions, or all the processes, all the message that intended to be sent to the back end will be stored here in the message queue. This is very important because what if a network would fail here? A network will fail. So what will happen? So the message wouldn't be lost. So dili siya mawala. It's because naka-store lang siya in a queue format, so that when the connection being been restored will be restored in the future, so the process will continue. So this is very important. The broker and the integrator, they will make sure that the data sent from the web client to the backend service will arrive, even if it will arrive later or sooner or later. So at least it arrived. Make it asynchronous. It's because of the integrator and the broker. So hopefully you understand, and vice versa. So when the backend service return the process request, so it will the broker will also perform a queue for it. What if ever a network would fail going back from integrator to the web client, so still the data is being organized in a queue format in the broker end. So this is very important, the integrator and the broker. So this is some sort of the whole idea of being an asynchronous. So it's necessary to make the entire system dynamic in the dynamic setting or dynamic environment of a business. So we don't want clients uses our system and then eventually your system would fail. So in order to avoid a failing system, so one solution is to take advantage on the asynchronous message. So I hope you understand this. Okay, so leave a question if this is somewhat unclear to you. Okay, next is in order to implement this sort of technology, like implementing a broker, implementing this asynchronous idea of a message being passed from client to the backend service. So we have to install these type of technologies, the RabbitMQ or the Redis. But in my experience, going back when I was working on my thesis, or on my thesis in my master's degree, so I used RabbitMQ that time. So it's very efficient, convenient to use because it has a graphical user interface that you can rely upon. It's easy to reconfigure or configure things on your queue. It's easy to configure here message queue and the reply queue because the RabbitMQ offers a graphical user interface. I don't know enough about Redis, but maybe we could explore this one. So I highly suggest that you would study in advance or benchmark about RabbitMQ and Redis. But in this course, we will be using RabbitMQ. So you can study in advance what's the advantage and of RabbitMQ over Redis or Redis over RabbitMQ. So it depends upon your preference in the future. But in this course, we will be using RabbitMQ. The technology that we will be using are Java, Python, and PHP. Might be involved, no? C++, C#, JavaScript, and Node. No, I'd like to correct. We will be using Java. So there are these things can be implemented in different programming language and scripting language. So for Java, it's a programming language. For the Python, it's a scripting language, and as well as PHP. C++ is a programming language. C# could be, I think it's a scripting language, and of course C is a programming language. JavaScript, it's a scripting language, and Node is a scripting language. So hopefully you take note of that. Okay, so we will have a separate discussion for XML parser, but to give you a general idea of what are these things is I just included here in my discussion. So of course, XML parsers and DOM are for parsing XML documents. So that's the idea. So there are advantages of using SAX over DOM, and there are also advantages of DOM over SAX parsers. To give you an idea, when you have this application and you use a SAX parser, so XML data being parsed in the SAX would become a SAX events. So when application access it on the SAX parser end, it will be faster because it will access it as if it was an event. Okay, so it offers a faster sense of assessing data. So SAX parser immediately feed all the data into the application in a SAX event manner. So application don't really necessary or don't bother enough or bother too much on assessing the data being passed from one system to another, because when SAX interacts it will feed the data into the application as an event. So what's the advantage of being passed as an event? So the application would immediately consume those data as an event in a top to bottom approach. So it would be faster. Don't worry much about this because we will have a separate discussion for XML parsers. Okay. Also for the DOM parser, let's see what's the meaning of SAX. Maybe we could search on the internet. So SAX is a simple API for XML. So yeah, Also for the DOM, it stands for document object model. So when XML is extracted or being parsed by a DOM parser, so it transforms the data into a DOM tree. So this the application can take advantage of the data being formed into a DOM tree because the application can perform a DOM calls. So this is somewhat advantageous also in the end of the application because when the application requires a specific data, it could perform an algorithm fast enough to search specific data within the data, no? So that's the idea of transforming a data into a DOM tree. Unlike this one, SACS events, algorithm for searching is somewhat limited. So it's inefficient in a sense when you have this bulky data in the sense. But in a sense of DOM3, having a bulky data, the application won't be bothered. It's because it could perform fast enough in terms of assessing a specific data within a bulky data because the data is being transformed into a DOM3. So it could take advantage on a an algorithm for searching. Say you want to search for a specific node or a specific data, so you could jump right into the data. Okay? Because of a specialized algorithm or special algorithm being dealt with or being used. Okay? So that's the idea. So why do you have to learn this approach, techniques, and technologies? It's necessary, no? Is because when we will be deployed in the future, we will be experiencing or encountering different different technologies, different architectures. So this is some sort of preparing you for that kind of profession. It's very important, no, that in terms of systems systems that are communicating, you have to learn different type of technologies. What are the techniques involved on the process on the fly, on the process of sending a message on the other system. So you can take advantage of what are the different approaches, techniques of the programmers involved, the team, no, of the developers. So yeah, it's very important as it will prepare you for the future. So that when you integrate a specific component of two or multiple systems that are currently communicating, so you won't be having a problem anymore. It's because you can leverage the idea of available technologies, available techniques, and available approaches and methods. So yeah, so integration on let me see on the syllabus, inter-system, no? So giving you more idea about integration or integration of software. So it's a technique for combining existing software components to form a complete system. So a technique daw kuno of combining existing software components to form a complete system. So let me open my Miro. So say for instance, allow me to use a Miro. So I hope you like this one. So say for instance you have this S1 or the system 1. So let me zoom forward. So you have this system 1 and then system 2. Okay, so these are currently communicating. Okay, so It's a techniques for combining existing software components to form a complete system. So, say for instance, this system is all about the HR system, and this system is all about the planning system. So the idea here is, say this is enrollment system, and this is for enrollment system, or ito registrar system. So currently they are communicating and they are sharing resources or data, no? So they are sharing data. So if you are tasked to create additional system, say this system 3, so how would you do it? Say, keep in mind that you cannot, there are instances that client won't allow you to touch the current system that are running. It's because it will stop the company's operation or the business operation. So it becomes harder on your end. So how would you implement, or how would you include this system on the process of being involved on the current process? How would you do that? So this is the question. So this is a very hard task. So luckily, we need to learn different technologies, no? Say for instance, these are the technologies. So we have these different technologies that should be included on the process. So all you have to do is to connect your system on that technologies, and that technology will now be easily incorporated with the existing technology. So that's the advantage. So the idea now is that all of these systems could perform a specific transaction, because the idea of the client being, or task you to include additional system, is that to form a complete system. Say for instance, enrollment system, registrar, and then you have this additional system to just to do guidance and counseling, say for instance, no? So this process is for guidance and counseling system. So in basically the idea of, say let's assume that the idea of guidance and counseling system would rely on the student record from the enrollment system and with the student information in the register system. Therefore, S3 could operate in terms of acquiring data from the enrollment system and the register system. So that could form a good counseling for each students. So yeah, so you can implement this system along with the technology techniques you will learn from this course. Okay, so I hope that's easier to understood. So okay, and then it includes, no, integrating at least one existing software, yeah, as we did, developed in the past with no plan for its symmetric integration with another components in the future. Again, developed in the past with no plan for its symmetric integration with another components in the future. So another challenge is that what if one of these system or existing system is the developers of these developers of this system did not develop the system in a sense that it could be used in the future, something like that. So what will happen to this system? How would you leverage the idea of integration? This is faulty. So that's the challenge. How would you incorporate your additional system that would connect to this system? So that's the challenge, no? Because former devs aren't really care about how the system would go in the future, because say for instance there are reasons like clients have minimal budget of developing this system in the past. So the client also, other reason also would be that the client lack of budget or wanted to develop the system in a short period of time. So there are many cases. So in the future, this could become a really a problem, or really a challenge for the new developers to implement additional component for the system. So okay, so yeah, when we talk about integration of software, it deals with approaches and techniques that connects people, applications, platforms, and databases. So um, the main goal of making additional system is that you have to consider when implementing additional component to the existing system, is you have to consider people. That is why I mentioned bitaw nga make sure no nga ang ato ang system is dynamic enough to the ever changing environment or ever changing nature of a business, because na mga client diha or mga customer nga labad kaayo, no, na mga customer nga grabe na yun mag-complain, dali ra dayon mawala ang trust, no, na mga trust issue. So yeah, you have to really make your system work, no, as much as possible. So you have to really do whatever it takes, no. You have to really use necessary equipments and tools just to make your system work, no, in a specific period of time, no, or a specific given time, no. Also applications, no, we have to really learn different applications, techniques, developers are also involved in the people. So how the previous system being developed. So na mga developers sa una, grabe na kay ka mga tiguang, di kabalog object-oriented programming, di kabalog different techniques. So ang unsa may tendency, ang ilang gi-develop nga system, grabe kay mga obsolete, no. Ni work, okay man, dugay na gigamit sa company, pero mo lagi to ang problem kung ang company mag-upgrade. So lisod kayo na siya nga system i-handle for integration, no. So muna siya, usa na siya sa mga challenge, no, apart sa people and the application. So platforms, no, daghan kaayo mga servers, ang iyang mga configurations, napay networks ng mga platforms. So you have to really learn those things. And databases, no, na schema, na giun sa pag-store ang database. Say for instance, this out from the two systems, kanira nga system ang connected sa database. So mangita tag database ba. Ingon ani man ang forma sa database. Yeah, this is the database. So say for instance, we have this database. So and all of the information of the entire system, no, the process information, the process data are being stored here in the database, and this database is only connected on the S2. So the S2 is the only system allowed to connect with the system. So that is why the S1 should connect on the S2 in order to acquire the same data that the S2 being used. So in order that the enrollment could operate, so it has to be connected on the S2. So this is the challenge, because this type of architecture is somewhat slow or inefficient to manage, because what if this connection would become faulty, or would error, or would cause would have a problem. So therefore the enrollment will stop, the operation of the enrollment will stop. So we don't want that. Many people won't want that, no, don't want that. So we have to resolve this type of issue. We have to provide an immediate solution for it. So later in our succeeding discussions, so this will be highlighted. Okay, so yeah, So, so that's the challenge, guys. We have to learn the schema. No, say for instance, you will again develop additional system. So that would connect to the S2 in order to acquire the database. And one solution would be to connect directly on the database. So what will happen? The devs will have to, the devs of this system would have to learn how this system, how this database goes, how to maintain this database, what are the schemas, what are the algorithm to assess this database, no? So that's the bigger problem. So meaning it could require additional amount of time, additional resources, additional expertise for devs. So syempre mag-require kag highly skilled ng mga devs just to understood your database. So meaning mahal po na sila bayad. So it would cost additional expenses for the company. So is that what you really want in the future? Is that how you are going to give advices for your boss, for your clients? So it depends, no? Other devs would, or other business consultants would require that we connect here instead of directly connecting to the database, because it's a risk when the S4 directly connects to the database. And what if this S4 could become vulnerable for hacking? So meaning the database are now exposed in the outside world. So that's really a challenge. Okay? So we don't want that this database could easily be acquired by attackers. Attackers would really not just acquire data but damage this database. So yeah, and then in general application, we also have this application integration. The idea of application integration is that not just integrating systems, but actually application that talk to each other. So the idea here is that, say you have this okay na tani, no? Okay na tani. So if ever na mo yung mga question, so be specific. Sir, sa imuhang discussion sa 4 minutes nga part, sir, ano yung question. So, okay? So say for instance, unsa man po dining application integration, say say sige na lang ikaw nagbuhat ng Excel, Microsoft Excel. Then napoy gabuhat sa lain sa Microsoft PowerPoint, no? PPT. So nganong unsay editon nimo diri sa Excel mo reflect man dito sa imong PPT. Possible na siya, guys, no? So meaning dili lang mga system nag-share og data, also mga application, mga specific applications intended for specific use. So those are applications. So how did they become connected? How they share information? So that's the idea of application integration. So the application integration is assist in unlimited sharing of data, business process among connected applications or data sources without making major changes to the applications or data structures. So data structures is an algorithm or a method of how you structure or how you establish the idea of assessing your data. So that's the idea of the application integration. So in general, integration means is a process of connecting multiple independently developed application. No, these are independently developed applications or system using incompatible technologies. So basically, S1 uses a different technology. Also, the S2 uses a different technologies, and they are very incompatible. How did you make them? How users or how the devs somehow connect them, no? Communicate them that S2 could possibly share a data padulong dito sa S1. Basically, the data being shared from S2 is written in, say for instance, Java. And when being migrated padulong dito sa S1, this is now a Java format. So how would you consume this if the S1 is written in PHP? So that's the challenge, no? So again, integration is a process of connecting multiple independently developed applications using incompatible technologies or heterogeneous applications or technologies to form into a single organization-wide system with information flowing seamlessly. So this is the idea. We need to make things seamless. So, mao na mention ako before nga kung naay gani client transaction or process being done on the system should be capable enough to handle the request or the client process, even if the network is down, even if the database is down. So you'll have to use some sort of asynchronous message, okay, just to queue all the process that whenever mubalik ra ang connection, so i-continue to niya, so at least wala dili ma-lost ang data. Okay, so seamless dapat, no, among the integrated systems or components. So for the inter-system communication, so it's the ability to connect two or more heterogeneous system to share input, output, storage devices. So this is somewhat high level than the system integration. It's a inter-system communication, involves even more heterogeneous system. The idea is to share input na good, share output, and the storage devices, and even the processes, no, to send messages. So this is high level. For the inter-system, you have to deal with messages, not just files, database, or objects that we share, but message, no, to each other by means of shared input and output channels. So we will be highlighting this, no, in the future. So leveraging the use of DCOM, Corba, and RMI. So these are the top, no, technologies being used to share inputs and outputs, no. So we will be discussing this in the future. Also for the web service, in order to share data over the network, so we'll have to use these architectures, no, WSDL, the SOAP, the UDDI, and architecture for creating using the web service. Especially this will be used when two systems are communicating over the network. So we have to rely on the web service because on top of the internet we have this web. Okay, we'll also be dealing with socket programming. So we will reprogram our network in order to act, no, the network would act based on our preference. Also protocols, so we will decipher the idea of UDP and the TCP. How could you take advantage on UDP over TCP, and how could also take advantage on the TCP over the UDP. So these are very important. So most industry uses these protocols to take advantage to take advantage efficiency over over performance. Okay, so yeah, there are aspect of inter-system communication. So I hope you have this a bit of understanding for the inter-system, because we will be discussing this in the future even more, no. So hopefully just stay with me. So for the aspect of inter-system communication, we have the software integration. So the problem is to integrate them into one larger system, satisfying and combining requirements within the newly formed environment. So that's what I did earlier, you know. In order to improve the current system, you'll have to include additional system, no, to form a complete system. So that's the idea of inter-system. So this is somehow can be called as inter-system communication. Okay, And then functional or technology integration. In terms of inter-system communication, you'll have to include new function or new technology within the system. So we can also think of this as inter-system because we implement new system in general. No, we implement new function for to improve the current system of enrollment and register system. So this is the idea of guidance and counseling. So this system should provide a new functionality, just what I did, or use of the new technologies while preserving the original system functionality. So we preserve the original functionality of S1 and S2. Incremental engineering, so new technologies and or more functions that can be integrated within the system. So the problem is to design the system with such future integration in mind. So dili ta pareho atong mga devs before nga kung nag-develop ani nga system without considering the future use of this system. So dapat dili ta ingon ana, dapat kita nga mag-develop og mga new function, new system. We are this dev. Suppose that we are this dev and we develop this new system, we make sure nga this system could operate, could be used on in the future, that whenever na ay i-integrate na pud nga another system that would connect to this system, ang mga devs din dili na ma-problema. Got it? Okay. Next is what are the fundamental challenges of integration? Application integration needs to provide efficient, reliable, and secure data exchange between multiple enterprise applications. So integration must deal with multiple applications running on multiple platforms, in different locations. So this is somehow additional challenge for integration, the network itself. Okay, we have this main system and we have this additional subsystem and another subsystem. So one idea is unreliable and slow network. So what will happen that the integrated system 1 would fail? So you should have a backup, integrated system 2. Okay, so integration solution must transform data from one computer to another across network. Another challenge is that things are being distributed. So just what I mentioned previously, that only the system 2 is connected to the database. So that's the challenge when you integrate additional system. It might be you require the devs that the system 4 would directly connect to the database. So you'll have to consider a lot of things. Okay, so in terms of integration, so that's another fundamental challenge. How would you leverage the technologies in order to take advantage on this setting? So every applications runs on completely separate environment, as database storage is not shared among applications. Some of the architectures relied on file transfer, so we will be discussing that in the future. In terms of methods of integration, so how we incorporate those methods into a perfect system. Making sure that the system could operate in the ever-changing or dynamic environment of business. So another challenge is any two applications are different. So mo to heterogeneous siya, unsa man ani mo pag-integrate, no? So dapat na kay mga method of interfacing. So one of the example is in interface para ma-integrate, magkitaay sila. So i-interface nimo ang mga functionality ining app 1 nga naa located sa other server. I-interface nimo. So kung imong interface, other devs would see it, with leverage the use of your interface, the specifications of those functions, how it can be assessed for the other applications located on the server to use. Okay, yeah. So an integrated solution needs to be able to interface with all other technologies. Another thing is that change is inevitable. So it's normal that changes happen all the time, most of the time, if not most of the time, sa business nga setting. Especially for you, manarbaho mo nas mga dagko nga industry, no, maka-encounter gid mo mga businesses nga would change monthly, quarterly, or even yearly. So you'll have to expect that kind of changes. So dapat prepared ka, aware ka of whatever technologies, whatever it take, whatever function it takes, no, just to implement what the client wants. So for this discussion, you can take leverage on the references I have attached. So you can refer on the wso2.com, the Studocyo, and the Axum in University Department of Computing Technology. So there are links. So again, if you have questions, please drop it on the forum that I'll be attaching below to this video in the LMS. So thank you for listening and have a good day.